Now we are going to talk about the amplitude. Amplitude means a length. Actually, the maximum displacement of wave making particle from the equilibrium position is called the amplitude. Amplitude means this distance, the maximum displacement, or from this position to this position is called the amplitude. Amplitude is one kind of displacement, but the maximum displacement from the equilibrium position, and the amplitude's unit is meter. Now we will talk about the wavelength, which is very important. There is the definition of the wavelength, as you can see. Let me explain the wavelength. The wave making particle starts its oscillation from this position, and after completing its oscillation, like up, down, down, up, up, down, down, up. That means after completing its oscillation, it comes back to this equilibrium position, and during this time the wave covered this path like AE. So AE distance is called the wavelength, and this is denoted by lambda, and the unit of lambda is m. Now we are going to talk about the longitudinal wave, which is just opposite of the transverse wave. In transverse wave, the angle between the direction of the wave and the vibration of the wave making particle was 90 degree, and there the angle will be 0 degree, or there will be no angle. Example, the sound wave. As you can see, these are the layer of the air. These are the layer of the air, and there is a tuning fork which is vibrating. When the tuning fork vibrates, it puts pressure in the air layers like this. As a result, the layers contracts. As the sound moves through the air layers, there creates contraction and rarefaction. There is the contraction, there is the rarefaction. It puts pressure there, there creates contraction, there rarefaction, contraction, rarefaction, and by creating contraction and rarefaction, it goes or moves through the air layer. So you can see the contraction and rarefaction. The adjacent contraction and rarefaction creates the wavelength, which is lambda, and the direction of the wave is this. So the direction of the wave, and the vibration of the particle are parallel to each other. So this wave is called the longitudinal wave. Now we will discuss about the relation between the frequency at the time period. As you can see, the relation between the time period and frequency is inversely proportional to each other. That means the more time period, the less frequency, or the less time period, the more frequency. And the relation among the velocity of the sound and the frequency of the sound and the lambda means the wavelength, is V is equal to F lambda. Thank you very much.